Hello, everyone. Welcome to Brain Blitz Audios. In today's episode of Cbse Board Exam, we'll be dealing with previous year questions of mathematics in Cbse Board Exam. The chapter that we'll be dealing with is the 11th chapter in the grade 12 syllabus for Cbse, and the name of the chapter is Three-Dimensional Geometry. Today's questions are pretty long and complicated, so I urge you to watch every single second of this video in order to get the three questions inside your head. With having said that, let's move on to our first question. Find the distance between the points 7, 2, 4, and the plane determined by the points A, 2, 5, minus 3, B, minus 2, minus 3, 5, and C, 5, 3, minus 3. So over here, we have the points A, B, and C, which are points present in a plane. So when we're asked to find out a plane determined by the points A, B, C, it is understood that these are non-collinear. And so we're to use the equation of a plane passing through three non-collinear points. So that formula is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. So these are a set of 9 elements. We're taking their determinant, and that determinant will be equal to 0. And this is the equation of a plane passing through three non-collinear points. The determinant of these quantities is equal to 0. So over here, x1, y1, and z1 are the coordinates of the point A. x2, y2, z2 are the coordinates of the point B. And x3, y3, z3 are the coordinates of the point C. Let's plug in the values. X minus 2, y minus 5, z plus 3, x2 is minus 2, minus 2 minus 2, minus 3 minus 5, and 5 plus 3. Moving on to x3, y3, and z3, it'll be 5 minus 2, 3 minus 5, and minus 3 plus 3. The determinant of this will be equal to 0. Now, the first row will still be the same, x minus 2, y minus 5, and z plus 3. The second and third rows can be operated upon to get minus 4, minus 8, plus 8, 3, minus 2, and 0. And the right side is equal to 0. Now, let's expand the determinant along its first row. So x minus 2 into minus 8 into 0 is 0, minus 2 into 8 is minus 16. And then for the second term, it will be a minus. Go back to the chapter determinants to find out y. And y minus 5. And minus 4 times 0 is 0. Minus 3 times 8 is 24. Plus the last term, z plus 3, into minus 4 times minus 2 is 8. Minus of minus 24. And the whole term will be equal to 0. Let's start solving the brackets. So x minus 2 times 16 minus y minus 5 times minus 24 plus z plus 3 times 32. And that will be equal to 0. Let's multiply. 16 times x is 16x minus 32, and minus of minus 24 is plus 24, so we'll get plus 24y minus 120 plus 32z plus 96 is equal to 0. Now, let's write that equation as 16x plus 24y plus 32z minus 32 minus 120 plus 96 is equal to 0. And minus 30 minus 120, so 120 plus 32 is 152. 152 minus 96, so 12 minus 6 is 6. 14 minus 9 is 5, so we have minus 56 here. So 16x plus 24y plus 32z minus 56 is equal to 0. And now we can take 8 common, so it'll be 2x plus 3y plus 4z minus 7 is equal to 0. So that'll be 2x plus 3y plus 4z minus is equal to 7. And therefore, we can write the vector equation as r times 2y plus 3j plus 4k is equal to 7. So this is the Cartesian form, this is the vector form, and that is our final answer. Let's look at our next question. Find the equation of the plane that contains the point 1, minus 1, 2, and is perpendicular to both the planes 2x plus 3y minus 2z equals 5, and x plus 2y minus 3z equals 8. Hence, find the distance of the point P minus 255 from the plane obtained above. So first, you have to obtain a plane, then we have to find the distance of a point P from the plane obtained above. So here, we have a point 1, minus 1, and 2. So the equation of a plane contains a point 1, minus 1, 2. So let's mark these as x1, y1, and z1, the coordinates. And let's write the equation of a plane passing through a point. So that is a into x minus x1 plus b into y minus y1 plus c into z minus z1. So let's plug in the values. A into x minus 1 plus b into y plus 1 plus c into z minus 2. And that will be equal to 0. So that is the equation of a plane passing through the point 1, minus 1, and 2. So since our plane is perpendicular to the two other planes, 2x plus 3y minus 2z equals 5, and x plus 2y minus 3z equals 8, the normal vector of our plane, the given plane, the plane that we need to find, so normal vector of required plane will be the cross product of the two planes normal vectors. So over here, the normal vector n1 will be equal to 2i plus 3j minus 2k, and n2, that's the normal vector of plane 2, is I plus 2j minus 3k. So our normal vector n, the normal vector of our required plane, can be written as I cap, j cap, k cap in the first row, and then 2, 3, and minus 2, the values of n1, 1, 2, and minus 3, the values of the second normal vector. Now let's expand this along the first row. So that'll be I cap into 3 times minus 3 is minus 9. Minus of 2 times minus 2 is minus 4. And then minus j cap. And then it will be 2 times minus 3 is minus 6. Minus of 1 times minus 2 is minus 2. Plus k cap into 2 times 2 is 4. Minus 1 times 3 is 3. So that'll be equal to I cap into minus 5 minus plus j cap into 4 plus k cap into 1. So minus 5i plus 4j plus k is the normal vector of the required plane. So from the normal vector, we'll get our direction ratios. So A will be minus 5, B will be plus 4, and C will be equal to 1. Now remember our earlier equation, A into x minus 1 plus B into y plus 1 plus C into z minus 2 equal to 0, the equation of a plane passing through a point. Let's put in the direction ratios, the values of the direction ratios in this equation. So it'll be minus 5 into x minus 1 plus 4 into y plus 1 plus 1 into z minus 2. And that will be equal to 0. On multiplying, we'll get minus 5x plus 5 plus 4y minus 4 plus 4 and plus z minus 2 equals 0. So then we'll get minus 5x plus 4y plus z plus 5 plus 4 minus 2 equals 0. So 5 plus 4 is 9. 9 minus 2 is 7. So minus 5x plus 4y plus z plus 7 equals 0. And I'm converting minus 5x to positive 5x. So I'm multiplying minus across all of these. So I'll get 5x minus 4y minus z minus 7 equals 0. And on converting it to standard Cartesian form, we'll get 5x minus 4y minus z equals 7. So this is the equation of the plane, the Cartesian equation of the plane. And now we need to find the distance of the point P minus 255 from the plane obtained above. So again, A, B, and C. So now we use the formula for distance of a point, that is, for in this case, minus 255 from the plane 5x minus 4y minus z equals 7. We take minus 2 as x, 5 as y, 5 as z, and our equation, that is d is equal to ax plus by plus cz minus d, whole divided by root of a squared plus b squared plus c squared. And we put that entire thing under a modulus. So now let's put in the values here. So d will be equal to 5 into minus 2 plus minus 4 into 5 plus of minus 1 into 5 minus 7 whole divided by minus 2 the whole square. No, not exactly minus 2. A is 5, so 5 square plus minus 4 the whole square plus minus 1 the whole square under root. And then everything under a modulus. 5 into minus 2 is minus 10. 4 into minus 5, 5 into minus 4 is minus 20. Minus 1 into 5 is minus 5. And then there's a minus 7. Whole divided by 5 square is 25. Minus 4 square is 16. Minus 1 square is 1. Everything under a root. And yes, 10 plus 20 is 30. 30 plus 5 is 35. 35 plus 7 is 42. Over here, everything has a minus, so it's a minus 42 whole divided by 25 plus 16 is equal to 41. 41 plus 1 is equal to 42. So minus 42 by root 42 whole modulus. And since it's inside a modulus, everything here will become positive. 42 by root 42. So the final distance d will be equal to root 42 units. That is the distance between the point minus 255 and the plane 5x minus 4y minus z equals 7. That is our answer. Let's move on to the final question. Find the distance of the point 2, 3, 4 from the line x plus 3 by 3 is equal to y plus 2 by 6 is equal to z by 2, measured parallel to the plane 3x plus 2y plus 2z minus 5 equals 0. So in this question, we are given a point P having, let's consider this as P, having the coordinates 2, 3, and 4. Let's consider them as x1, y1, and z1. And we have a line x plus 3 by 3, y minus 2 by 6, and z plus z by 2. So now let's write down the coordinates. So x is equal to 3 lambda minus 3, y is equal to 6 lambda plus 2, and z is equal to 2 lambda. How did we get these? X plus 3 by 3 is equal to y minus 2 by 6 is equal to z by 2 will be equal to a constant lambda. And so for each of these, I've just rearranged it in the form of their coordinates. So x, y, and z. But these aren't just x, y, and z. These are x2, y2, and z2. Again, coordinates. Now let's consider the point to which these coordinates belong to as a point T. So when we know 2 points on a line, we can find out the direction ratios. So direction ratios of a line with 2 points will be equal to x2 minus x1, that'll be A, y2 minus y1, that'll be B, and z2 minus z1, that'll be C. So x2 is 3 lambda minus 3 minus x1 is minus 2, and y2 is 6 lambda plus 2, and then there's a minus 3, and z2 is 2 lambda, and minus z1 is minus 4. So we get the direction ratios. A is equal to 3 lambda minus 5, B is equal to 6 lambda minus 1, C is equal to 2 lambda minus 4. Now, in the question, the line given is measured parallel to the plane 3x plus 2y plus 2z minus 5 equals 0. So our line PT is parallel to plane 3x plus 2y plus 2z minus 5 equals 0. Over here, the direction ratios, capital A is 3, capital B is 2, capital C is also 2. And since the line is parallel to the plane, so our line PT is perpendicular to the normal vector of the plane. And so when two vectors are perpendicular, we use AA plus BB plus CC is equal to 0. So direction ratios for each of the components, X, Y, and Z. And so we multiply that and then we add them together to get 0. So this is a condition when two lines are perpendicular. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Now let's put in the values of A, B, C, and capital A, capital B, capital C. Capital A is 3, small a is 3 lambda minus 5, plus capital B is 2, small b is 6 lambda minus 1, plus capital C is 2, small c is 2 lambda minus 4, and the whole of that is equal to 0. So let's multiply. 3 times 3 lambda is 9 lambda, minus 3 times 5 is 15, plus 2 times 6 lambda is 12 lambda, minus 2 times 1 is 2, plus 2 times 2 lambda is 4 lambda, minus 2 times 4 is 8 equals 0. So 9 lambda plus 12 lambda plus 4 lambda will be equal to 25 lambda, minus 15 minus 2 and minus 8 will be equal to minus 25. So 25 lambda minus 25 is equal to 0. So we can write lambda as 25 by 25, which is equal to 1. So the value of lambda is 1. So let's plug the value of lambda into the coordinates of t. So that's x2 is 3 lambda minus 3 is equal to 3 into 1 minus 3 is equal to 0. And y2 is equal to 6 lambda plus 2, that is equal to 6 into 1 plus 2, which is equal to 8. And z2 is equal to 2 lambda, which is equal to 2 into 1, which is equal to 2. So the coordinates of the point T are 0, 8, and 2. So we're now going to find out the main part of the question, the distance of the point P from the line x plus 3 by 3, y minus 2 by 6, and z by 2. So the distance will be between the points P and T. So distance between points P and T. This is a simple use of the distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square, and put that under a root. X2 is 0 minus x1 is 2, so 0 minus 2 the whole square plus y2 is 8 minus y1 is 3 the whole square plus z2 is 2 minus z1 is 4, and then the whole square, and put everything under a root. So that is minus 2 the whole square plus 5 the whole square plus minus 2 the whole square. So 2 square is 4, and 5 square is 25, and 2 square is 4. So our final answer, the distance of the point 2, 3, 4 from the line, which is parallel to the plane, will be equal to root 33 units. And that is our final answer. So that ends this episode of Cbse board exams. So there are a lot of questions on inverse trigonometric functions. We can't do all of them in a single video due to lack of time. However, what we can do is we can make more videos on 3D geometry. So we have a lot of videos on 3D geometry and other chapters in Cbse board exam. I'll provide the link for the playlist in the description down below. So be sure to check it out. And also, if you want to check out more of our useful and interesting content, like learner words, mind maps, NEET preparation, memory hacks, etc., so then you can subscribe to our channel, which is Brain Blitz Audios. You can hit the notifications button down below so that you can receive updates about our latest content. So until the next episode, take care, stay safe, bye-bye for now.